Hi everyone, welcome to CodeTav Management. So we are continuing with our Spring Boot tutorial. So I have already explained the one-to-one mapping, but today actually I will deep dive this one-to-one mapping and maybe some topics what I've covered I will repeat those one as well. But some of the topics I will cover more deeply. So mainly the architecture and the internals I will discuss here. So that's the motto of this lecture. I hope that will be helpful for you, and through that, the one-to-one mapping journey I will end. So just think, I hope you have seen the one-to-one mapping annotations in Spring Boot, but do you actually know what happens under the hood? Like why does the post request work perfectly, but a get request crashes sometimes, and for that reason your application will have some infinite recursion error. So today we are doing a complete architectural deep dive into the JPA one-to-one mapping, and we are moving past the basics and looking at how Hibernate actually decides the foreign keys. So why composite keys are a nightmare, and the exact difference between the persist for cascade type and merge in the cascade type. So finally, I am going to give you some um, important interview statements that will instantly prove to any technical architect that you know your stuff. So let's build better backends. Okay. So the thing first I will discuss is unidirectional versus the bidirectional. Okay. But before that, what exactly this one-to-one object relational mapping? So you know in database like one row in table A is linked to exactly one row in table B. But in Java, how we will do that? One object holds the reference to one object only. So like a user exactly has the one address and an employee has exactly one ID card. So this is different from like one to many, like one user, many orders, and many to one, many orders, one user. Okay, so now the unidirectional versus the bidirectional. So that is the core design concept. Okay, that we need to know. So in relational databases, like one-to-one means like one row in table A links to exactly one row in table B. In Java, it means like an object holds exactly one reference to another object. So like a user details having one user address. Okay, so more frankly, in unidirectional design, the user knows about the address, but the address has no idea who the user is. Okay, so this is incredibly clean, less prone to bugs, and highly recommended for most APIs, right? So that is our unidirectional concept. And by default, Hibernate creates like if you know when you use the Hibernate, so it by default it creates the foreign key column using the field name underscore ID. Okay. So like if user address your user address will become user underscore address underscore ID. But in real company, you don't let the warranty SEO schema. You take the control using join column. Okay. So that's why we use the join column. Okay. So here you can see the one-to-one. Here we have the user address and user address no idea about the user details. So this is simpler, less bugs, and recommended for most APIs. But for bidirectional, both sides know each other. Like user address and user details, both have the idea of it. So user details, like one-to-one, you have seen like private user address. Okay. And in user address, like into one-to-one, mapped by user address here. Okay, and here we have given the private user details, user details. So only one side owns the foreign key, that is the owning side, and other side is the inverse, like that is the object owner. Okay, now point three is about the foreign key internals. So that actually I was telling that by default Hibernate creates a foreign key column using the field name underscore ID. Okay, so like user address becomes the user address ID. Okay. And but in real company, you don't let the warrant guess your schema. You take the control using join column, right? So here you can see the through the join column, you can take the real control in the production. So for the production environment, this join column is the important topic. So without join column, Hibernate auto decides, and with join column, you can give it like this @ join column, the name, address ID, reference column name, ID. Okay. So in production, you must explicitly declare your foreign key constraints using the join column to ensure backward compatibility with legacy databases and adherence like to company naming standards. Okay. So that's why what we have achieved, column name is controlled, useful for legacy DB naming conventions, DB migrations, and this is mandatory in real companies as well. Okay. Now, the composite key, like why it is dangerous. So we will now talk about the danger of composite keys. So a composite key uses multiple columns, okay, as a foreign key, like the street and pin code both, okay, as a primary key mapped via embedded ID. Okay. So industry rule is like avoid the composite keys unless forced. So they result in slow joins, hard indexing, difficult caching, ugly APIs. Okay. So avoid composite keys unless it is forced. Okay. So what is the good solution is use the surrogate key, means like long ID. Put business fields as normal columns. Okay. Some standard columns. Okay. Now we will deep dive in the cascade part. So I have discussed already about the cascade, but this is the most misunderstood concept. So that's why I want to explain this again. So cascading defines like how entity state transitions propagate from a parent to a child. So when JPA executes an operation on parent, it automatically executes same operation on child. So like first of all, like cascade type dot persist, like here for but before that, like see, like when no cascade, when you are saving, you are persisting the user, so address is ignored, but with cascade your address will be auto saved, as you like you have seen, right? Like whatever we will do with the parent, then the same operation will be done with the child as well. So when the address and the user, so user is your parent, right? So here when no cascade, then when you are saving the parent means the user, then your child will be like child is your address that is getting ignored. But when you are doing with the cascade, okay, then then when you are saving the user, so you are going to save the parent, then your child means the address will be auto saved. Okay. Now, first of all, there is CascadeType.PERSIST. So like it handles the insert logic mainly, and Hibernate generates the ID for the child and insert the child, and then insert the parent with the foreign key in a single atomic transactions. Okay, so you can see here again, like generate ID for address, insert user with foreign key, atomic transaction. Okay, now here also in dummy code I have added, like not dummy code, this is like the dummy concept you can see, like save user, so it's persist user, persist address. Okay, like with cascade, with cascade, save user, then address will be auto save. Okay. Now the CascadeType.merge, so it handles the update logic. So your persist actually handles the insert logic, but Cascade.merge that handles your update logic. In Spring Data JPA, so save method acts as a merge. So you can identify exists. Then if you only use persist, then it updates the child entity. Will fail silently. Like that is the one warning as well. Like if you only use persist, then like it updates the child entity, and that will fail silently. So like here you can see like ID, like some JSON object. Okay. Now it has the ID. Okay. Name, new name, user address. It has the address. Now see ID, update. Then without merge, child will be ignored, as through merge you are going to do the update logic. If parent will be updated, the child will be also updated. Right. So without merge, child will be ignored, and with merge, child will be updated. Now, why persist alone is dangerous? See, like insert will works, okay? Like through the persist insert logic will be there. Update fails silently, but what it will cause? Now data mismatch will be there, and partial updates happen. Hidden bugs will be there. You got it? So, like, if you will do the only persist and you will not do the merge, then what will be happen? So your child will be updated, like child will be inserted, merge will be not happen, so child will not be updated. So that's why some data mismatch will happen. Okay, so uh, like you have for better case, like in suppose in for production or something, you always do persist and merge both, like insert and update both. Okay, now cascade type of remove, like that is basically for the delete strategy. So it deletes the child when the parent is deleted. So it's critical for some preventing orphan rows like that. Okay. So without remove, user deleted, address becomes orphan row. Okay. As your address is the child. Okay. So with remove, what will be happen? Both deleted. So critical for GDPR banking PII systems. Okay. Like suppose your address will be needed. Like if that address will be useful for some other entities or some other components, and if you will delete that, then it will be issued for other cases. Okay. So in that way, we have the cascade type dot refresh as well, detach as well. So what refresh does, that also I have discussed in my previous video, but I am again explaining. Like cascade type dot refresh, what it does, like it bypasses the first level cache and forcing the JPA to fetch the latest state from the database directly. So useful for the real-time data like financial balances. And what the detach will do? So detach removes the entity from the persistent context. So JPA stops tracking data changes. Okay. So refresh basically bypass the first level cache, and it will force the JPA to fetch the latest data from the database itself. Okay. So that is useful your real-time data when you want to check the real-time data like the balance check, or like in your change data capture, you can learn about the CDC concept. Okay, that is the change data capture concept. So there also you can use that refresh. Always it will check the data from database itself, like what the data updated, what is the latest data, and from detach, it will remove the entity from fetching the data from the persistence context. So what will be happen? If it will be done, then it stops the tracking from the data changes. So it is useful for heavy read-only batch jobs. So production standard is always like cascade will be persist and merge both. That is the open state like some safest uh, approach it is actually to prevent accidental data deletions. So, what is the first level cache? The hidden layer it is, like every entity manager has the persistence context. Okay, and during transaction, DB is hit once. After that, all reads come from memory. So this is why insert response has full object and get response false. Okay, insert response has full object and get response false. Why? DB will hit once. After that, all the reads come from memory, not from the DB. Okay, so insert response has full object but get response false. So cascade type.phrase, like cache bypass that I have discussed already. Okay. So it ignores the caches, fetches from DB, and with cascade child also replaced, used in stock prices, bank balance, real-time scenario. So that refresh, like whatever we do during our real time and more complicated parts, like the tradings, stock market, right? So the latest data we need to check always, right? So for those cases, we always need to do the entity management dot refresh. So there we need to use the cascade type as refresh. And detach, like when JPA loses the control. So after detach, JPA stops tracking from the persistent context, no data checking, no auto update, and used in read-only services, heavy batch jobs. Now, lazy versus eager, like this is the real performance engineering. So eager is by default for one-to-one mapping and always executes SQL join to fetch the child table, and it leads to memory waste and slow APIs. Okay. So select star from user details, you join user address. Okay. A. So you have seen here what I have just told you. Like it always executes a SQL join to fetch the child. You can see like this user details is the parent, user address is child. So it's doing join operation. Okay. And so unnecessary joins, memory waste, slow APIs. Now lazy is default for one to many, means child loaded only when accessed. So only executes, like it creates a proxy object. Okay. So like for about the Hibernate proxy, right? So it will create a proxy object and only executes a select query when the getter method is explicitly called. Okay. So suppose we are doing the create user address, then Hibernate fires the select star from user address. Now, why get APIs fail but post succeed? That I have told here. See, like insert response has full object, get response fails. So that is the question now. Like why get API fails but post works? So during a post, the entity data is already active in the first level cache. Like what is the first level cache? The persistence context. Okay. So like Jackson serializes it successfully. And during a GET request, Hibernate returns a lazy proxy. When the HTTP response tries to serialize it, the database transaction has already closed. So that's why it will throw lazy initialization exception. So that's why GET fails, but POST works. So you can see here again, like objects already in memory. Okay. So as it will take it from the first level cache. Okay, as entity data is already active in your first level class persistent context, so you will get the object from the memory. So no DB hit is happening, and Jackson able to serialize it successfully, right? But for GET request, Hibernate returns lazy proxy. So when the HTTP response tries to serialize it, the database transaction already closed, so no data. Jackson crashes, and this is the core ORM concept. And lazy initialization exception you will get. Now, what is serialization hell? The real production problem. One can ask you about this. Have you faced this serialization hell? So yeah, in bidirectional mapping, Jackson will serialize step by step. Like uh, the flow is like infinite recursion in bidirectional. So like suppose you want to fetch the address, so it will go to user, then address, then again user, then address. So that is the infinite recursion in the bidirectional. Okay, in that infinite loop will happen. So in bidirectional mapping, Jackson will serialize this user, then address, then again user, then address infinitely, and that will cause the stack overflow error. Jackson keeps serializing forever. So solutions ranked by quality. Like worst hack is you have to use JSON ignore. So it's basically deletes the data from the payload. So that is the bad idea. That is the worst solution. So that is the worst solution. Now, okay solution. Okay solution is you can use the JSON managed reference and JSON back reference. So JSON managed reference and JSON back reference. So that is the best. So that is the just a second. That is the okay. Now the best one. Now that is the best one and industry standard as well. So JSON identity. So it uses the primary key to avoid the duplication. So see, like if you will use the worst, that's the hack. So that deletes the data from the payload. That's the bad solution. Okay. And then JSON managed reference and JSON back reference you can use for the okay solution, like better solution. And best, like for industry standard, you can use the JSON identity info. So JSON identity info, what it will do, like you can uh, it uses the primary keys to avoid the duplication. So that's why infinite loop will not be there. Okay. Now, now I will tell you about some ultimate industry best practices. So some interview also you can face this type of questions and they can ask you like what are the best practices for you one-to-one mapping and what concepts you follow. You can tell in that way. So like never return the entity from the controller. Always you need to map the data to a DTO. Like, what is the DTO? DTO is the data transfer object. So never return the entity from the controller. Always you need to map with the DTO. Always you need to map the data to a DTO. Okay. Next is avoid the cascade type.all. Okay. Use only what you need. So like prefer the lazy fetching. Lazy fetching also you need to prefer. Okay. Combined with the DTOs. Now, not eager. Okay. Now, avoid the bidirectional unless needed. So, avoid bidirectional mapping unless strictly required by business process. Never expose composite keys. Okay. Always use single long ID. Always states test, insert, update, delete, get. Okay. Now, use transactional wisely. Lazy works only inside transaction. Okay. Lazy only will work in the transaction. So transaction about this transactional annotations, I have made 4 videos. Okay, 4 videos in this channel in the Spring Boot discussion. You can go there and check those 4 videos. So interview level killer statements, you can literally say this like cascade controls, lifecycle propagations, not relationship. Lazy loading is implemented using proxy objects. Tab is not insert, it's merged based on identifier. First level cache exists per entity manager, not globally. Infinite recursion is a serialization problem, not object relational mapping problem. So that is serialization problem. And to solve this, we have 3 solutions. One is worst, one is okay, one is bad, like best. Okay. So cascade controls lifecycle propagation, not the relationship itself. Save is not in insert. Okay. So it's a merge based on the identifier. So that's the deep dive of the one-to-one mapping. If any concept I have left, then just comment below. I will discuss about that as well. So thank you, everyone. Maybe in the next lecture, I will what I will cover. I will cover. Let me think. After that, I can explain about the one-to-one mapping done. I can explain about the what about the JPA relationship mapping and querying, some native queries, criteria, API specifications, API. Those also maybe I will cover. Okay. So stay tuned. Do like, share, and subscribe, which will motivate me. Okay. So thanks everyone. Bye.